Good morning, or afternoon, or evening, or whenever you're watching this. Today is week 1, day 3, right? Yeah, week 1, day 3. Sorry. I'm Mr. Roll, and I'm here with Miss Lee. We're trying to keep social distance while still staying in the frame of the camera. Anyway, for announcements for today, many of you should start noticing a difference in your lessons. The platform that we're using from lessons is changing, so we're no longer going to be shooting videos like this in front of the actual classroom. We're switching over to shooting videos on our laptops, just in case we all kind of get stuck at home where we have to stay home. Your teachers can continue teaching you your lessons. So you're probably going to be seeing that starting today, or maybe even tomorrow for most of us. All right, so it's time for us to do our joke of the day, and then on to our pledge. Miss Lee, take it away.
What do cats eat for breakfast?
I don't know, Miss Lee. What do cats eat for breakfast?
Well, mice. Crispies, of course. Kellogg's Mice Krispies.
Mice Krispies. Okay, Mice Krispies. Get it? That's cute. Get it? Because they're cats and they eat mice. Yeah. Okay.
Exactly.
All right. So go ahead and take it away. Let's do the pledge.
All right. You need to get the pledge.
Oh, you gotta tell little kids to turn and put it around.
All right, kids. So for those of you at home, make sure to take your hats and hoodies off. Stand at attention, please, with your right hand placed over your heart. Follow me for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, thank you so much, Miss Lee. Let's go ahead and get to class. Later, guys. Hey, 7th and 8th graders, welcome back for another day. I got tired of sitting at my desk recording stuff, so I'm trying to stand in front of the board for a little while longer while we still can and teach you from the school. I got kicked out of my own classroom because someone else is recording in there, so I'm coming to you today from Miss Kaufman's kindergarten class. It doesn't matter, I just need a board. Let's go over the agenda for the day. So, first up, we're going to have a life skills conversation. As most of your lessons are, it's just kind of me talking to you. We have social studies. Again, we're going over a little more current events, and we will be talking about the history that you were reading the other night. Then we have a literature discussion. Now, I actually forgot the literature discussion that I was supposed to put on day 2, so I'm just going to plop that in on day 3, and we're going to be one day behind on literature. I will include the link, just like I promised yesterday, for the audiobook file, so that so that everybody can listen to the story, so we don't have to have somebody read it to you. That way, also the reading or the video file will be a bit smaller today, so that you'll have to watch a little bit less, which might be kind of nice. Then, of course, we have a science class. We're talking still about physics work. Today, we are beginning to discuss newtons and joules. And then lastly, of course, we have Group 1 and Group 2 for math. Now, I do want to point out that Miss Kimmy's grammar class is going to be in here. I think we're going to have to put that under a separate link. So I think after you're done watching this video, you're going to need to jump in and go to a separate link for Miss Kimmy's grammar class. But we're going to make sure to include that today. I forgot about it yesterday. Really sorry about that. Okay, and so this is the agenda for the day. Okay, so it's a little bit weird with this light in my face, but I'll just keep talking. Today, I wanted to talk about boredom, being bored. We have a lot of distractions today. There are, the internet is so big, there's always something to do or something new to see. It's important to note that boredom is important. And meditative thought is important. So you know how in class from time to time we do mindfulness exercises where I actually force you to sit there and focus on something? Oftentimes the mindfulness exercise is focusing on my voice. Sometimes I ask you to think deeply about a certain topic. It's important for you to be able to clear your thoughts of other subjects and focus your thoughts in kind of like a laser. That's a really important life skill. But another important life skill is to be able to accept and cope with boredom. It's important for you to not always have to be entertained by something. When we are on, for instance, and I think I've used this example before in class, but when you're watching Sesame Street on PBS, or I think it's on HBO now, when you're watching Sesame Street is constantly jumping back and forth between different topics because small children, the way their minds are wired, you cannot expect a small child to focus on an abstract concept for more than 30 to 90 seconds. That's kind of their limit. And so what Sesame Street and these other children's programs usually do, like Daniel Tiger's Neighborhood and things like that, is they will take like a deep or complicated concept and they'll break it into like usually 90-second chunks. Like they'll have their letter of the day and they'll say, okay, you know, here's the letter of the day, and then 90 seconds later they'll break into something else and they'll bring back the letter of the day and then something else and then letter of the day and something else. And the reason why they're doing it like this is to keep the kids' attention. Now, you're still kids, but you're growing into young adults. And so it's important for you to be able to extend your attention span. And part of extending your attention span is to not always have to fill the times where you're bored with entertainment. You know, we joke about TikTok in class and YouTube and Vine videos, and Vine's like not a thing anymore or whatever. But it really is not the best for you. And so as you're staying at home during this time, you know, where you're kind of stuck, deliberately make yourself bored. And I know that sounds kind of weird, but take the time to deliberately be bored and exasperate yourself. Now, why would you deliberately be bored? Why, if you have the option to be watching something and to be entertained, why would you want to deliberately not take that option? Okay? Well, let's talk about that. All right? When we talk about higher levels of thinking, okay? People who think deeply about subjects that are important, they usually do that in times where they're not being entertained, okay? Isaac Newton wrote his famous Principia, okay? You know how we talk about Newton, like you learned when you were really small, that Newton was like sitting under a tree and then an apple like fell on his head, and that's where he thought of gravity. He looked up at the moon and like the idea of gravity came to him. That story is not 100% accurate, but there are a lot of truths to it, okay? So as if I remember correctly, Newton was a student in London, and I think he was a grad student, or maybe he was a lecturer in London. And very similar to COVID-19, there was a plague. And as this plague ran through Europe and it hit London really hard, the people in London who had the money to leave London got out. And the other people had to quarantine, just like you and I are doing right now. And so it was during one of these periods of quarantine that Isaac Newton was bored. And as I remember the story, I believe he was sitting under a tree and he began contemplating the moon and the force of gravity. And that led to the landmark work in physics called the Principia. I'm probably saying that wrong, and someone on the internet is like mad at me right now. But the main point is Newton's groundbreaking work that was the basis for all of physics until Einstein came along was created during a quarantine time, just like we're having right now, and it was created when he was bored. And so you might be saying to yourself, Mr. Roll, like an 8th grade, 7th grade boy or girl, I'm not going to create a landmark work of physics, so I'm just going to watch TikTok. Fair point, okay? But it's important for you as an individual who, I have high hopes for all of you, okay? I think that all of you have the ability to do great things in your life, not because you're just my students, but because I know you, because I've spent the better part of a year at least with all of you, 2 years for most of you, and I believe that you are capable of great things. Now, unless you're willing to learn to work hard and think a little deeply, you're not going to be able to do those great things. And again, part of thinking deeply is being able to focus and being able to tolerate being bored. So again, to wrap up our life skills lesson for the day, I would very much like all of you to sit and be bored for at least 15 minutes today. That's your life skills homework. Sit and do nothing for 15 minutes. No television, if you have a radio, no phone, no iPad, no internet device of any kind. Just sit for 15 minutes and admire your room. Look out the window for 15 minutes and see what the people are doing outside, if there are people, okay? Practice boredom, because boredom does lead to higher level thinking. All right, that's it for life skills. Let's go on to social studies. I can hear some of you right now thinking, Mr. Roll, I am practicing boredom. I'm watching this video. Again, fair point. But practice boredom without watching your boring teacher. Thanks, guys. All right, let's start talking about current events. Again, I know the interview was a little bit long yesterday, but I hope you thought it was interesting to hear about a corner of the world and how they're dealing with COVID-19 that you don't really hear about in the news. I was talking with Alan just this morning, and he told me that right after the conversation that we had, his city was put under lockdown. So they're taking this very seriously, even though in the whole country they only have 8 confirmed cases. They see the writing on the wall and what's happening. So rejoice and be happy that we are not taking this overly seriously. All right, well, let's get back to talking about economies. So like we discussed the other day, okay, I'm gonna stand on this side because I have this goofy light that's making a shadow here. So like we discussed the other day, an economy is basically like the collection of all the businesses in a given area, usually in a country or in a state or in a city. If we have an expansion of the economy, if we have an economic expansion, that again means that businesses are growing, more people are getting jobs, people who already have jobs are getting paid more money. Contraction is the opposite, okay? The businesses are shrinking, people might be losing their jobs, people are taking jobs for less money when they get them. That would be a contraction. So let's begin to expand these definitions today. And we talked about this a little bit in class. Specifically, we're discussing a contraction, okay? Now, Steve Mnuchin, one of, you don't need to know who he is, but somebody who's very important that knows a lot about economics and business, who is currently in a position of power here in the United States, just today admitted, or is today or yesterday, said that there's a very good chance that we are currently living in a recession period. And so that's why this is important. That's why this is a current event. If you are at home and you're also wondering about Arizona state standards, these also cover state standards for learning about basic economics, okay? So when we have a contraction, we often view contractions using 2 different terms, okay? We can have an economic recession, and to a much larger magnitude, we can also have an economic depression. Now, it's important that you understand that entire books have been written about what a recession is and what a depression is. And so when we talk in just middle school about the basic concepts and ideas behind what a recession or a depression is, we make the definition overly simple so that it's easy to get it's easy to understand the concept. Now, like many things in life, you can study this much more deeply, but right now this is just the top surface of what it's like. And so, Aiden, I know that you know what this is, but for the rest of us who don't remember, okay, a recession is when the economy is shrinking, for an extended period. I'll just say an extended time, okay? And the unemployment rate is at or approaching 10%. Okay? So again, the economy is shrinking for an extended time, and the unemployment rate is at or approaching 10%. Now, we'll unpack what the unemployment rate is in just a minute, okay? But the important thing to understand that a recession is a kind of contraction, okay? And a recession is kind of on the better side of contraction, okay? If you have to have a contraction, a recession is not great, but it's not the worst thing that's ever happened. A recession that's not very bad is a normal part of life, okay? Just like if you caught a cold, that's just a normal part of life. We all catch colds, we all have to get sick sometimes, and if you're gonna have to get sick, getting a cold, not the worst thing in the world, okay? And so a recession is a kind of contraction, and a recession doesn't have to be so bad. Now, recessions can be very bad, okay? But they don't always have to be. All right, let's go down to depression. Now, a depression is also a kind of contraction, but depressions are terrible, okay? They're always terrible. Depressions are like the worst thing ever for the economy, okay? And so when we're talking about depressions are also in a time where the economy is shrinking for an extended time, but the unemployment rate is at or approaching 30%, okay? Economy shrinking for an extended time. Oops. Unemployment rate is at or approaching 30%, okay? Now, so there are times, you know what? We need to talk about what an unemployment rate is first before we jump back into this, okay? So next, let's talk about the unemployment rate. So you hear this on the news a lot if you pay attention, the unemployment rate. So an unemployment rate is the percentage of adults who are willing and able to work who don't have a job, okay? And so a few key things. It's the percentage of adults, so we're not talking about kids, all right? Percentage of adults who are willing, okay, meaning they want to work, and are able, which means they have the physical ability to work, okay? If you are an adult who wants to get a job, but you are stuck in the hospital because you broke your leg, okay, you are not able to work because you are lying in a hospital bed, okay? And so if that was the case for somebody, they would not be counted in the unemployment rate. So, again, let's write this out. It's the percentage of adults. Okay, I'm going to underline the word adults because this is not children. Willing and able to work you can't find a job. Okay. So one last time, The unemployment rate includes anyone who's looking for a job, who's an adult looking for a job, they want a job, and they're able to do a job, but they can't find a job. And those are the people that we include in the unemployment rate, okay? Now, it's important to know what normal is, okay? So if we're talking about the unemployment rate here, okay, and I'm pretty sure that you can see this side of the screen. Let me double check. Yeah, so I still have some room to work with over here. So if we're talking about unemployment rates, okay, if we talk about, let's talk about a 4% unemployment rate, 3% unemployment rate, and then let's jump up here to let's say a 6% unemployment rate. Okay, we'll say 6% plus, okay, or 6% or more, or higher. No, that's the wrong higher. That's a homophone or whatever. 4 or 6% or higher, 3% or lower. Okay. So if we're looking at kind of like a scale of unemployment rates, okay, an unemployment rate of 6% or higher would be not good. This is not good. Okay, an unemployment rate around 4%, I would say, is good. Okay, so again, 6% or higher is typically not good. Okay, it's not the end of the world, but it's not good. Okay, 4% unemployment rate, I would say, is good. I mean, it's not great, but it's a strong unemployment rate, and it's good. Now, 3% or lower is amazingly good. I'll just put amazing. Okay, if your country has an unemployment rate of 3% or lower, that's incredible. Okay, so again, just to give you an idea, so in the United States, we're usually aiming for an unemployment rate just close to 4%. Okay, maybe like 3.8% or maybe like 4.5%, because a 4% unemployment rate is really good. Another term that we use to describe a 4% unemployment rate, I should move because my shadow is casting here. The unemployment rate at 4% is usually referred to as full employment. Full employment. What that means, kids, is that at a 4% unemployment rate, virtually anybody who wants a job can get a job, almost. Okay, so again, an unemployment rate of 4% is really good. Now tomorrow in our current events talk, we're going to talk a little bit more about recession, depression, and unemployment rates and how that all relates to where we are and where we're going. Again, kids, the concepts of recession and depression are much more complicated than what I'm sharing with you here. These are really just oversimplifications, but it's important that you get that good idea because a lot of Americans don't even have a good idea about what these concepts mean. Okay, so you're already ahead of the curve. Let's do history. All right, let's take a minute and talk about history. Yesterday, you read about the Emancipation Proclamation, talked about the beginning of the Civil War. So I'm not going to spend too much time on that today because you have more Khan Academy to do on that. And also, I don't know, but I feel like we're spending a little too much time on social studies, and I want to devote more of your video to your other subjects. But briefly, every year, or every time I've talked to this with people about specifically like the Battle of the Bull Run, everybody is always surprised about the picnics, right? That people from the north were actually picnicking to watch the battle and whatnot. They're like, wow, that's really dark, you know, that people would actually be going to watch other people get shot, right? And it is dark, right? But it's not really like, a lot of times we like to say, oh, those guys were so silly, that was such a dumb thing to do, right? But human beings, not just Americans, but human beings have used violence as kind of like entertainment for a long time. And so, like, even today, if you're watching like Game of Thrones or anything like NCIS or something like that, a violent movie, okay, the Power Rangers, all right. Whenever you're watching something that is violent, just remember that back in the 1860s, they didn't have television. And so, you know, back in the Roman times, they would be in the Colosseums and they watch gladiators beat the snot out of each other and sometimes murder each other, right? They used to watch people get eaten by lions, right? You know, villages all across Europe and frankly all across the world used to have public executions that people would come to for, again, entertainment. And so it's not that unusual to think that the people in Washington, D.C., who really thought that the Union would quickly and swiftly just, again, beat the South, they viewed it almost as entertainment. They all wanted to be there. They all wanted to be able to tell their grandkids, I was there when the North beat the South. And a lot of them, that's what they thought that battle would be a decisive victory for the North. And they thought that it would bring a swift end to the war, which, as you know now, was exactly not the case. So that kind of explains that. Now for tonight, we're going to go on in our Civil War. You have 3 more links from Khan Academy that I need you to go through. And tomorrow we're going to be talking a little bit about the pressures that Lincoln had on his shoulders. Now, days 1, 2, and 3 have all been review. If you're in my class, you've heard these lessons before and you know all about this. Now, day number 4, though, we start getting into some new stuff. We're talking about the magnitude of the Civil War, not just in blood, but the magnitude of the Civil War in principle. Because the Civil War is probably the most, is one of the top 3 most serious wars the United States has ever been in on the topic of principle, what it stood for. And we're not just talking about slavery, but that is a big part of it. Okay, let's go ahead and jump into science. How am I doing, Coach? Can they see me? All right, I'm here in outer space with Coach Fryer right now oh yeah, I should be like waving around a little bit to explain something for science. You see I'm bobbing? This is high quality effects here, kids. So, no, I'm actually filming, Miss Frank. That's okay. We're gonna keep on going. So, kids, if I'm in outer space and I'm somehow magically alive and breathing because of negative pressure and no oxygen, whatever, there's no friction. I'm in a frictionless environment. Everything is floating. And here, I have a can of, what did I grab? Rust-Oleum Professional Marking Paint. All right. In outer space, where there is 0 friction, if I have anything that weighs a kilogram, kids, for us Americans, a kilogram is 2.2 pounds. So I have this thing that weighs 2.2 pounds, okay? If I apply enough strength to this thing that I make it float away at a speed of 1 meter per second. Coach, can you grab me a meter stick? Wait, those are attached to the wall. We can't grab those off the wall. So if I throw this can, or if it's floating in space, I just have to like push it like that, okay? And if I push it at a rate of 1 meter per second, okay, here's my meter stick. As you can see, the meter stick is so large, it doesn't even fit in the frame of this video. It starts over here, goes all the way over here. I'm pushing this can at a rate of 1 meter every second in outer space where there is no friction. If I do that, then I have expended 1 Newton of strength, okay? So 1 Newton of strength is enough to force 1 kilogram of mass in a vacuum where there is no friction, 1 meter in a second. That might be super complicated. That's why I went through all the trouble of coming to outer space to explain this to you. Again, 1 meter per second for 1 kilogram of mass, and that strength, or that force is the wrong word, but that amount of magnitude of power, whatever you want to say, is 1 Newton. Okay? That's a Newton. Newtons are complicated. Thank you. All right, I think it's gone. Okay, I'm just hanging out in Miss Kimmy's room. It looks like my room is being recorded in, and I can't find a tripod anymore, so I'm just looking at the board. We left off in literature, 20,000 Leagues Under the Sea. We just read the chapter South Pole, and then I think you guys just finished the chapter Accident or Incident, okay? So briefly, let's review those two chapters. Let's talk about it. So in the chapter South Pole, if I remember correctly, the Arctic, the South Pole, had not been fully discovered. The South Pole had not been fully, I guess, walked across. People hadn't actually explored the entire South Pole until sometime around 1910 or 1920, somewhere in there. And so when Jules Verne wrote this chapter on the South Pole, it was completely from his imagination. So the chapter, the South Pole, and then the preceding chapter, which you should have already read, Accident or Incident, that was all completely a work of imagination. And so we talk a lot about how Jules Verne was kind of a visionary and how he invented so many of these concepts in his books that today we just take for granted, like an underwater breathing suit, for scuba divers, or having a submarine with a giant spotlight on it. Okay, all of those things he invented, and so these last two chapters are a complete work of his imagination, which is kind of special. So talking about the characters themselves, I always thought that this chapter on the South Pole was very interesting because the character Captain Nemo, he's so devoted to hating the land. He doesn't want to go ashore on the islands when they stop by, right? He wants to be able to do everything underwater. He even buries dead people underwater from his crew when they die, right? And so he is so obsessed with staying in the ocean. And then when it comes to the South Pole, he changes. When it comes to the South Pole, he wants to be the guy to stand there and put the flag in the ground. And they're like, whose country are we claiming the South Pole for? And he's like, no country, just claim it for me, Captain Nemo, big letter N. And so it's really kind of weird, right? That he's like this ocean guy, and then just because he's the first, or he thinks he's the first, right? He's obsessed with it being him. And so, as it turns out, Captain Nemo's obsession with this exploration gets them all in a lot of trouble. And so, in the chapter Accident or Incident, as you should have read, so the Nautilus, it's time to get out of there, because at the end of the South Pole chapter, okay, again, I'm doing this all from memory, so I apologize if I flip a few things around. Captain Nemo goes on and on, or it was Aronnax, one of the two goes on and on about saying goodbye to the sun. And so, as we talked about in class, the North and South Pole, they're generally dark for about half the year because of the Earth's tilt, and so the sun's over here and the Earth is tilted. So the North Pole gets sunlight for like 6 months, and then when the Earth goes all the way around, sun's over here, the South Pole gets sunlight for like 6 months. And so they are in the literal last day of sunlight for the next half a year, and they're putting the flag in the ground on the South Pole. And so they are getting out of there right in time for them to do one last reading. So they take one last reading with their instruments, looking at the sun and the tilt of the Earth to figure out exactly where they are. And they're like, hey man, let's scram. So they get in their little sub and they start going away, and then boom, they run into ice. Okay, I think they said it was like an iceberg that tipped upside down, right? And remember, kids, sonar technology, the idea of using like a sonar ping to figure out what's around you, that not been invented yet. This book is written at the same time as the Civil War, and so even having an underwater boat is like bananas. And so they're stuck, and they don't know how to get where they're going or what they're doing. And so they hit forward, boom, they run into some underwater ice. They go backwards, and all of a sudden, boom, they run into more underwater ice. There's ice above, ice below, and ice on both sides. They are boxed in. And remember, the sub has to surface very often to get fresh air. They're literally trapped underwater, and they've been underwater, I think, for like 3 days or something like that, and I believe they only have like 5 days of oxygen, and so they are stuck, and they're all worried about one, freezing to death, and two, being basically being choked out. Okay, they're all afraid of asphyxiation because they're afraid of running out of oxygen. So anyway, that brings us to our next chapter that I want you to read tonight. I am not going to force Coach Fryer to sit there and read the entire chapter to you again. Woo! Yeah, Coach Fryer heard me. Instead, what I'm doing is I'm going to attach the audiobook file as a link. For those of you in our class, you already have the audiobooks app. You can just listen to it and read along, whatever you want to do. But go ahead and give that chapter a read. I forget the exact name. It's something about not having enough air. Makes sense. And so either read it or listen to it or do both. And we'll talk more about this tomorrow. Thank you.
All right, let's go ahead and get started here. So this is bum 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 bum. This is week 1, day 3, group 1 math. All right, so let's go ahead and get started. All right, so group 1 math. The other day we learned about how to. What did we learn the other day? Oh yeah, we did area of a parallelogram. Okay, that was good. Okay, and so you guys remember that the area of a parallelogram or rectangle, okay, I'll put that in parentheses because it works for rectangles too, rectangle or square, and I guess rectangles or squares are technically parallelograms as well. Okay, so an area of a parallelogram is simply base times height equals area. Or if you're not good with just like abbreviations, I'll just write it out. Base times height equals area. Okay, there we go. All right, and then after we did the area of a parallelogram, we talked about the area of a triangle. That was nice. And the area of a triangle was almost the same. It was the base times the height. But remember, any triangle is just half of a rectangle. So it was base times height times 1/2 equals area. And this is not just area, this is area of a triangle. Okay. Now, there's another way that you can do this. Sometimes, I don't know which way they do it on Khan Academy because I was too lazy to check before I started this recording. Another way that you could do this is base times height divided by 2, okay, equals area of the triangle. Now, I don't want to get real deep into this right now, but I just want to remind you that multiplying by 1/2 is the same thing as dividing by 2. Okay, and so those are ways that we can calculate the area of a triangle. Oh, I apologize if you hear a bunch of rumbling in the background. I just rebuilt my RAID array in my home office, and my computer is shuffling around a couple terabytes of information to make it work properly. So anyway, that's what that is. It's just computer exercise in a way, I guess you could say.
Fitness-related questions. Search the health and fitness category of the skill store.
I just activated my Amazon Alexa because the wake word is computer. Anyway, all right, let's see here. I do that in class from time to time. All right, so we did area of a parallelogram, area of a triangle. And so we're going to continue on this idea of area. Today we're doing the area of a circle. And so an area of a circle is completely different than anything that we've talked about thus far, okay? Now, just to unpack the idea of area again, okay, area is the measurement of the space in a shape, okay? All right, guys and gals. So, and those of you who are non-binary, okay, if we are measuring the space in a shape, that is what is known as area, okay? So again, if we're getting the area of a rectangle, the area of a triangle, or the area of a circle, it's the same thing, okay? We're measuring how much space is inside of the rectangle, we're measuring how much space is inside of the triangle, and now today we're going to be measuring how much space is inside of the circle, okay? So we're just measuring the space on the inside, okay? Now, rectangles and triangles are really nice because they have an easy thing in the height and in the base, okay? So rectangles and triangles both have a base down here and a height over here. Whoops, that's like another B, okay? Oh, come on. I'm getting better at this slowly. Okay, see, again, okay, a height on both sides and a base on the bottom, okay? Now, circles have no such luck, okay? And so circles have a couple different things, okay? So the circles are named because of what's in the center. All right, and so if we have a line, this is a review. If you're in my math class, we've already gone over this a couple times, and if you're not in my math class, you need to know this to be able to do the work. So we can have a line that cuts through the middle of a circle, okay, and that line that cuts through the middle of the circle, that's known as the diameter, okay, the diameter, or just the letter D, okay. Now, if we have a line that starts at the middle of the circle, whoops. What am I doing here? Okay. If we have a line that starts at the middle of the circle and goes out to the edge of the circle, so it's touching both the middle and the edge, okay, we call that line a radius. Radius. Or just an R, okay? So with rectangles, we're working with base and height. With triangles, we're working with base and height, or height and base, okay? And with circles, though, we're working with diameters and we're working with radiuses, or radii, okay? And so that's just to start off there. It's a different beast, okay? Now, I also want to talk about what we already know, okay? So we don't get confused. What we already know. So we already know about a circle, and I don't know why I like the color red today, but I'm going to go for red. Okay, so we have a circle. We already know about the middle. We know what that is. We know what a diameter is. Okay, so we know that that is a diameter. It's the thing that goes to the middle, and we know again that a radius goes from the middle to the edge. So we know it's a radius. Okay, use my little green arrows here. Okay, but we should have also learned one other thing. And so again, for those of you in my class, this is a review, and for those of you not in my class, I just want to make sure that you're aware that you need to know this. Okay, we have a third measurement that's called a circumference. Okay, and so the circumference has an easy definition. It's just the distance around the outside. So it's the distance around the outside of a circle. So if the shape that I was looking at wasn't a circle, if the shape that I was looking at was any other shape, it would be called a perimeter. Okay, and so it's like a perimeter for a circle. Like a perimeter for a circle. Okay, so again, you can think of circumference like a perimeter of a circle. Okay, and so a circumference is different than a diameter or a radius, okay, because the circumference of a circle is the distance around the outside. I'm drawing that in yellow right here. And so the circumference is this yellow line that's the distance around the outside of the circle, okay? So again, a circumference is talking about the distance around the outside of the circle, okay? That's circumference. But area is talking about all of the measurements in the middle, okay? So please try not to confuse those two. Area is the measurement of the stuff in the middle. Circumference is the measurement of the distance around. Okay, so they're two totally different things, but they are easy to get confused, and I see middle schoolers doing this all the time. Okay, so let's talk formulas here. Okay, so my formulas Formulas, okay? I have two formulas, and let's take the one that you should know already. Circumference, okay? Circumference. So my circumference formula is circumference, or here, I'm going to take away that equal sign. Okay, my circumference formula is C equals pi times the diameter, okay? Pi times the diameter. Now, if we look at the diameter here, again, the diameter is this nice long line that goes through the middle, okay? It is double the distance of the radius. The radius is only half of the diameter, okay? So I can say that the circumference equals pi times the diameter, or I could also say that circumference equals pi times double the radius, pi times 2 of the radius, okay? So one diameter, remember a diameter, one diameter equals 2 radius, okay? And that's why this works, okay? Because the diameter, this, and 2 radius, this, they're the exact same thing because one diameter is 2 radius, okay? So again, my formulas for circumference can either be C equals pi times diameter or circumference equals pi times 2 radius, okay? Either one works. Either one is okay. So that's my formula for circumference. Now let's take a look at the formula for area. This is the formula for area of circles. Okay, and my formula for area of the circle is a little bit more complicated. It's area equals pi times the radius, but it's not times 2, it's the radius squared. Okay, so area equals pi times the radius squared. Now, I don't know of any quick and catchy way to understand this other than just memorizing it. The area of a circle is A equals pi r squared. Okay, so let's go ahead and do an example calculation and see how this works. Okay, so kids, you should also remember that pi is usually a value that equals either 3.14 or pi can also be the value of 22 over 7. Either one, if you feel more comfortable, using a decimal, you use the decimal value. If you're more comfortable using the fractions, you can use the fraction value. It doesn't matter which one you use, just use one of them. Okay, for this demonstration, I'm going to use the 3.14 one. 3.14 pi value. Okay, all right, so I have a circle. Here is my circle. It is very nice. I have a diameter. I have a radius. There we go. Let's say that my diameter is 10. Diameter equals 10. If my diameter right here is 10, then my radius, which is half of my diameter, would have to be 5. Okay, that kind of almost looks like a 6. Let me try that again. It would be 5. That still looks like 6 adjacent. Anyway, 5. There we go. Diameter equals 10. Radius equals 5. Okay? And I want to figure out my circumference, which my circumference is equal to pi times the diameter, or pi times 2 of the radius. And then I want to figure out my area, which equals pi times the radius squared. Okay? So first off, I am going to calculate my circumference. Circumference. Okay? And so to do my circumference, again, I'm going to take my diameter, and I'm going to multiply it by pi. In this instance, my diameter is 10, okay, because the line that cuts through is 10. Cool, okay? And so I'm going to get a diameter of 10 times 3.14, okay, which equals my circumference. And then 3.14 times 10, okay, gives me 31.4. So my circumference equals 31.4, okay? And so again, the circumference is the distance along the outside. There we go. Okay, so my circumference, the distance around the outside here, okay, is 31.4. Next up, let's take a look at the area. Okay, again, the area, the measurement of everything inside, not the distance around the outside. It's the everything inside. So area equals pi times the radius squared. Okay, and so my radius is 5. Okay, and so I have to take area times, or area equals pi times 5 squared. Okay, now I know everybody in every math class ever made for the past 100 years has learned the acronym PEMDAS. Okay, you ought to remember parentheses, hopefully I spell these right, exponents, okay, multiplication, division, addition, and subtraction, okay? All right, so I have to do the parentheses first, which means I have to take 5 squared, all right? And 5 times 5, or 5 squared, okay, gives me 25, okay? So I just want to show you every single painstaking step here. You get to see how the sausage is made, as they say, or they used to say, I should say. So we have area equals pi times 25. Okay, and now, oh, quick break. Can I charge it? Yes, okay. Sorry, my 4-year-old isn't here. So, okay. All right, Marshall, I'm in the middle of making a video, son, so you got to head out. Okay. Oh, wow, is it that late? Okay. All right, hey, I'm almost done, buddy. I got to remember to edit that out. If you're hearing this, I forgot to edit it out. So, all right, I have area equals pi times 25. Okay, so I got to do my multiplication here. I have 3.14, okay, times 25. 5 times 4 is 20. 5 times 1 is 5. Plus 2 is 7. 15, okay. I'm in my tens place. So 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Got to add them together. Get 0. 15, 5, 6, 7, 8, 7, okay. I have 2 decimal places to bump up here, so I bump the 2 decimal places back down here. I get 78.5, or 78.50. So my area equals 78.5, okay. Now, last final thought, I've been a bad math teacher, and I have not been using any units here, okay. So let's put in some units and see how that changes things. So that if this is 10 feet, and this is 5 feet, 10 feet, 5 feet, okay. If we go back here, we have 10 feet, okay. And so this becomes 31.4 feet, all right. Now over here, if I have my radius squared, if this is 5 feet, okay, 5 feet times 5 feet, remember feet times feet gives us 25 feet squared. And then this gives us 78.5 feet squared. Okay, so final numbers here. My area would equal, or I'm sorry, this would be, first we did circumference, okay? So my circumference, okay, circumference equals 31.4 feet, and then my area equals 78.5 feet squared. There we go, okay? So that's how we do it. Ladies and gentlemen, that is the basics of what area is and how it's different than circumference, and that's also how to solve it. So at this time, while I go back and get ready to post this video, I need you kids who are watching this video sometime in the future for me to watch the Khan Academy video that also explains this. So it'll be another time for you to see the same concepts, which is always good to see 2 different people teach it in different ways. And then I need you to do the rest of the Khan Academy work. All right, ladies and gentlemen, if you have any questions, feel free to email me. I wish you a good day and a happy rest of your math class. Yeah. All right. Talk to you in a bit. Bye. All right, welcome to math class. This is, what is this, day, oops, what's going on here? There we go. Okay, I believe we're now currently in, let's see here, we're still in week 1. We're on day 3, and this here is going to be group 2. All right, week 1, day 3, group 2. All right, group 2. So, as you all know, we've been solving systems of equations. Yeah. Okay, and so just a quick review. Today we are going to learn a third way to solve systems of equations, but we have our first way to solve a system of equations, which is the algebraic method. Algebraic. This is also, I call it plug and chug. Okay, where you just kind of like pop a value in there, see if it works. That's great. Okay. You know what? Honestly, even though we said that this is like one way to solve, it kind of is not a way to solve, to be honest with you, because it's really just guess and check, which that's not even a thing. And so, but you know, the book that we work out of says so, so you know, we'll just kind of call it that here. All right. So the second way that we learn to do it is using substitution. Substitution. Okay, that is where we figure out, you know, what one, how do you say, what we figure out what one variable means in terms of the other variable, and we plop it back in. Okay, and so we did that the other day. We also learned how to do this graphically. Okay, graphically, as you guys know, is we just graph both equations on a line, and the place where those two graphs connect, bingo, that's the answer. Okay, and so that's really the second or third way that we learned how to do it. And so today we're going to learn a quick and easy way to do these kinds of things. And this quick and easy way is the method of elimination. Okay, so today we are focusing on elimination as a method for determining, I guess, how to solve a system of equations. And this one is really cool. I think you guys are going to like this. So for elimination, we take a system, and in fact, I already got a system, and I double checked it to make sure it was super chill for you guys. In fact, you see my notes there. Gosh, I sound so old and dumb saying things like super chill. Whatever. Okay, I don't care. So we have 12x take away 3y equals 4,200. All right, so 12x take away 3y equals 4,200. This is a system, so I have my bracket sign there. 4x plus 3y equals 5,600. 4x plus 3y equals 5,600. Perfect. Okay. All right. So I have this system of equations here. Now, again, looking back on the past couple days, I need everybody to remember that this x is the same as this x, and this y over here is the same as this y down here. Okay? That's what makes a system of equations a system of equations. So when we're looking at the elimination method, okay, when we are trying to figure out the elimination method as a way to solve, what we're trying to do is we are trying to eliminate a variable by combining the equations. So I'm actually trying to combine these two equations together in a way that would eliminate one of the variables. And I want to point out, I made this one easy for us here, because if we combine the top equation up here with the bottom equation down here, we will automatically eliminate this y variable right in here. So I'm going to show you how to do this, and we'll do one or two more in practice, and then I'm going to make you watch a long Khan Academy video that is going to explain to you why this works, okay? So I'm just showing you how. Khan Academy will explain why, okay? So we're going to combine these two, and it's going to eliminate my y variable, and after I eliminate my y variable, I'm going to solve for x. After I solve for x, I'm going to plug the x back in, and then plugging in the x is going to allow us to find y, okay? So let's go ahead and do it. So again, basically all I'm doing is I'm combining the top equation, and I am combining it with my bottom equation. Okay, 4200. Okay, this is like a really advanced basic arithmetic problem. I'm just going to put my line of fairness in there, make sure everybody is lining up properly here. 4x plus 3y equals 5600. Okay, so my 4 is a positive 4, or my 4x is a positive 4x, that's a plus. My 5600 is a positive 5600, that's also a plus. So I just say 12x plus 4x gives me 16x. Here's the cool part. Wait, what am I doing? It's a plus. My bad. Okay, that's a plus right there. Negative 3y plus 3y eliminates my y. Elimination, hence the name of the method, okay? So that variable has been eliminated. Okay, hopefully all the red marks make that obvious. Okay, so, and then I add these two up and I get 9,800, okay, or 9,800. So what I'm left with when I'm done is 16x equals 9,800, and I have no y because it has been eliminated. Elimination, yeah. Okay, so now all I have to do is solve for x, plug it back in, and figure out what my y is. Okay, easy peasy. So I divide by 16 on both sides. I'm going to cheat really quick for the sake of time. And so we have 9,800 divided by 16, which gives me, this looks right, 612.5. Perfect, okay? So now I know it's 612.5. All right, I can take either one of these equations up here. It doesn't matter if I take the top or the bottom. Either one will work, okay? I'm going to erase all these yellow arrows here. There we go, okay. But yeah, I can take either one. Either one will work. They're both fine. So just for funsies, I'll take the bottom, the 4x plus 3y equals 5,600. Okay, wait, where'd my thing go? So 4x plus 3y equals 5,600. Good. Okay, separate it out. All right, then I'm going to plug in this for my x right there. So I get 4 and then 612.5, right? Plus 3y equals 56. Okay, so you saw it right here, okay? Up in here, I eliminated my y. But now that I figured out what the x value is without y, I can effectively eliminate my y by I can effectively eliminate my x by plugging in the value again, okay? So I'm plugging in the x there, okay? And so now I no longer have an x, I just have numbers and then a y variable, okay? So now the only variable that's on my board is y, and so I can solve for y because x is no longer there. Does that make sense? Okay, I have to cough. I promise I don't have coronavirus. Actually, I shouldn't promise that because who can say, right? All right, let's see here. 2450 plus 3y, there we go, equals 5,600. There we go, okay, and all of you good algebra students know this is a very simple problem to solve. I just take away 2450 from both sides, that cancels that out, and then I get 3y. You know, I'm going to try to mute some of this, so if you hear like this random muted kind of thing, that's me coughing, so I think it's just I've been up too late. So I get 3150, good. And then let's extend this just a smidge. Okay, divide both sides by 3, divide that out. I get y equals, what is this? This is 1050. Cool, okay. All right, so y equals 1050. X equals 612.5. Okay, and that is my solution for this system of equations up here. Okay, again, x equals what? 1050. Y equals, what is it, 6112? No, I switched it around, silly me. This should be, okay, this should be y. Oops, come on, man. Y and x. Okay, there we go. All right, so to review, I combine the one equation with the other equation, and I'm able to eliminate a variable, as you saw on the red part here. Once I eliminated the variable, I was able to solve for the other variable right here. Once I figured out what x was, I could plug the x back in. I could figure out what y was, and then I knew what x and y were, and then I was happy. Yay! Okay, so that is a basic problem with elimination. Again, the way that we do elimination is by eliminating one of the variables by combining my system of equations. Okay, I tested that system of equations as you saw before I began this lesson just to make sure I got it right. Let's jump into untested territory now, and I'm just going to make up a new system of equations. Okay, so let's say x plus 2y equals 24. Okay, little system bracket there, or that looks kind of gross. I'll try it again. Okay. By the way, you should get one of these little stylus and play with your iPad with it. It's a lot of fun. Let's say that 3x plus 5y equals, let's see, it's probably going to be a higher number unless it's in the negatives. So I'll just say, I hope this isn't too messy. Let's say 72. Okay? All right, so this is the system of equations that I just made up. All right, and so if we want to use the elimination method, okay, I have to combine the one equation with the other equation. Now, looking at this, it's difficult to do elimination here because I can't just combine these two equations and eliminate one of my variables, okay? If I add these two guys together, okay, I'm going to get 4x, and I'm going to get 7y, okay? So instead of eliminating a variable, I just make my variables bigger. So that's not what I want, okay? But the elimination method allows us to manipulate and change the equations, okay? I am using elimination. I'm actually allowed to manipulate and change the top and the bottom equations however I want, okay? So let's go back to the line of fairness idea, okay? So there's a line of fairness here, this yellow squiggly line that I draw. Remember, whatever I do on one side of this line, okay, whatever happens over here must happen over here, okay? As long as I'm doing the same thing here as I'm doing over here, I'm not actually changing my equation. Effectively, these equations remain the same, okay? And so, again, that's how the line of fairness works, kids. Okay, so as long as I'm respecting the line of fairness, I can manipulate the top equation or the bottom equation to make it so I can eliminate the other one in a way that makes sense by respecting the line of fairness. Okay, so sometimes it's better just to do rather than show. So what I'm thinking here, looking at these two equations, okay, I have an x right here, and then I have a 3x right here. If I could turn the top x into a negative 3x, it would cancel out with a positive 3x down there, okay? And so now I have to ask myself, how do I make this x a negative 3x? Well, I can turn x into negative 3x by multiplying x times a negative 3, okay? So if I multiply this by a negative 3, then I will be able to effectively make the x, again, a negative 3x, okay? And so, but remember, because I have to worry about my line of fairness, sorry if you heard some background noise there, one of my kiddos opened my office door. In order to make the x a negative 3x, I have to do this to the entire top equation up here. This entire top equation needs to change. So let's try it, okay? So let me rewrite my top equation, and I'll put it down here in the corner. So I have x plus 2y equals 24, okay? I'm going to multiply, here, let's see, line of fairness. I'm going to multiply both sides of my equation by a negative 3. Okay, so I distribute this out, or I rainbow it out, reverse rainbow there. Okay, and so I get negative 3x plus, I'm sorry, that's actually, I guess you could say plus a negative, plus negative 6y, okay, because 3 times x is 3x, and so it's a negative there. And so this is a negative 3, so it's negative 6y, okay? Now over here, when I rainbow this out or whatnot, okay, when I distribute it using the technical math term, okay, I should get what, 72? Is that right? A negative 72? I believe that's correct. Give me 1 second to think. Okay, it's 25 times 3 is 25. So 2, yeah, okay, 72. All right, so this is my new modified version of the top equation, okay? Now, I can take my modified top equation and combine it with the bottom equation to eliminate my x, okay? That is what I am about to do. So my bottom original equation is 3x plus 5y equals 72, okay? And so I'll put my line of fairness in here, just like that. And then I will go ahead and add this in. And so I have negative 3x take away 6y equals negative 72, okay? This answer is about to get a little weird, kids, okay? That crosses out because the 3x and the x cancel each other, all right? And then if I add the 5y plus the negative 6y, I get negative y, and I get 0 over here. So negative y equals 0. If negative y equals 0, then y equals 0. Okay? Whew, that's a weird answer, okay? Now, if y equals 0, what's going on here, okay? So we have to look back up here. Y equals 0. So I can take either one of these equations, either the top or the bottom, okay? And I just plug in my y equals 0. All right, so let's go ahead. I've manipulated the top equation quite a bit. Let's take the bottom equation again. 3x plus 5y equals 72. 3x plus 5y equals 72. Okay, I'm going to sub in the 0 for y. So I get 3x plus 5 times 0 equals 72. Anything times 0 is 0, so it becomes 3x equals 72. All right. We do our division. X equals, let's see here, what's 72 divided by 3? I'm going to cheat and use my calculator here. Okay, that gives us 24. Oops, 24. Okay, x equals 24. Y equals 0. And so the solution that I got for this is y equals 0, x equals 24. Of course, we always need to check the answer to make sure it works. Okay, so let's stop and think about this for a second. If y equals 0, that cancels out. And then x equals 24, and x equals 24, x equals 24. That works. Okay, so the top equation is good. Let's take a look at the bottom equation. Okay, if y equals 0, that cancels out. Okay, and then we simply get 3x equals 72. And if we divide 72, again, by 3, we get 24. X equals 24. It checks out. This solution works. Everybody see that? Okay. So again, just to review, okay, when I'm doing the elimination method, I'm trying to combine the top equation with the bottom equation in a way that cancels out one of my variables. And so sometimes we can manipulate it, just like right here. I manipulated the top equation, and I manipulated it to give me a negative 3x, so that when I combined this negative 3x with the positive 3x up here, it would cancel itself out, okay? And then I was left with 5y, take away 6y, it was a y and 0, all right? Again, in the elimination method, we are eliminating, I didn't spell it right, did I? Elit, that's supposed to be an I, that's what I did wrong. I know a couple of you are OCD like my wife, and so I just try to respect that, right? So eliminate a variable by combining the equations from the top and bottom, Okay. Later on, when you start hitting systems of equations that have 3 and 4 or maybe 5 equations, you're going to have to use all of these methods. Okay. You're going to have to use the elimination. All right. You're going to have to use the graphical solving, and sometimes you'll have to substitute. And then when all else fails, you'll just have to take a guess, plug in numbers, and pray real hard, and hopefully you get it right. I think I did that on screen the other day, and I was just kind of floored. Okay. So anyway, these are basically the 3 methods that we've learned plus guessing on how to solve a system of equations. Now, be good math students and go watch the Khan Academy video, which explains this concept in a way that is much more formal and civilized than your dear old Mr. Roll. All right, thanks everybody.